Greetings everyone. Today we're going to be talking about Lecture 9, or Chapter 9, Soil and Agriculture. And to start off, we have a quote from the Dalai Lama. And it's right here. The threat of nuclear weapons and man's ability to destroy the environment are really alarming. And yet there are other almost imperceptible changes. I'm thinking of the exhaustion of our natural resources, and especially of soil erosion. And these are perhaps more dangerous still, because once we begin to feel the repercussions, it will be too late. And on that incredibly somber note, we're going to begin our lecture. As I was saying, we're going to be doing Chapter 9, Soil and Agriculture. And this chapter will help students explain the importance of soils to agriculture, outline major developments in the history of agriculture, delineate the fundamentals of soil science, including soil formation and soil properties, analyze the causes and impacts of soil erosion and land degradation, explain the principles of soil conservation and provide solutions to soil erosion and land degradation. We're going to describe techniques for watering and fertilizing crops and offer more sustainable alternatives. And lastly, we're going to be summarizing major policy approaches for pursuing soil conservation and sustainable agriculture. As always, we're going to begin with another central case study. This time, Iowa's farmers practice no-till agriculture. Repeated cycles of plowing and planting since farmers first settled the region have diminished the soil's fertility, and turning the earth by tilling, plowing, disking, harrowing, or chiseling aerates the soil and works weeds and old crop residue in the soil to nourish it. But tilling also leaves the surface bare, allowing wind and water to erode precious topsoil. The conventional practice of tilling the soil after harvest instead turned to no-till farming. Rather than plowing after each harvest, crop residues were left atop their fields, keeping the soil covered in plant material at all times. As a result, the Nielsens are observing the condition of their soil improve. The Nielsens also find that no-till farming saves time and money. Along with no-till methods, the Nielsens are using cover crops, or crops planted to hold the soil in place between times that main food crops are growing. The Nielsens practice other conservation measures on their land as well. Moreover, the Nielsens avoid farming on lands that are sensitive or have poor soil. Conservation measures like these are saving the Nielsens and thousands of other Iowa farmers money, while protecting environmental quality and nurturing soil as an investment for sustainable yields in the future. No-till farming is not a magic bullet, and it isn't an ideal solution in every location, but in suitable regions, proponents say it can help make agriculture sustainable. So, soil is the foundation for agriculture, and especially so for sustainable agriculture. To begin with, agriculture is just the practice of raising crops and livestock for human use and consumption. We obtain most of our food and fiber from cropland, or land used to raise plants for human use. Rangeland or pasture is the land used for grazing livestock. Soil then is a complex system of disintegrated rock, organic matter, water, gases, nutrients, and microorganisms. For the above reasons, healthy soil is a key component of sustainable agriculture, agriculture that we can practice in the same way in the same place far into the future. So soil supports our agriculture. Agriculture and plants require healthy soil to get their nutrients that they need to allow the root structure to adequately hold up the plant and to retain water. Livestock then depend on healthy soil because they depend on the plants that are going to grow there. And soil has sustained our agriculture for thousands of years. And here we can look at soil. Organic matter in the soil provides nutrients and help with structure and water retention. Soil structure and texture influence root penetration and growth. So it's not just dirt, it's a lot of things and a lot of factors that impact how well plants growing there will grow. So agriculture rose 10,000 years ago. Different cultures independently came across the idea of agriculture, and evidence for the earliest plant and animal domestication is from the Fertile Crescent of the Middle East. Or Mesopotamia. Agriculture arose independently, at least in China, Africa, and the Americas also. Raising crops was a very good positive feedback cycle. Harvesting the crops required people to be sedentary, and being sedentary encouraged the planting of more crops. So more crops allowed for larger populations, and larger populations required planting more crops. And on this map we can see a couple locations where it was possible for independent origins of agriculture. Fertile Crescent's right there in the middle. So what happened 10,000 years ago to make this happen? Well, two really important things happened. The last ice age had just ended, and man had finally developed the technology to take advantage of this climate change. So industrial agriculture is what dominates today. For thousands of years, the work of cultivating, harvesting, storing, and distributing crops was performed by human and animal muscle power, along with hand tools and simple machines. An approach that we call traditional agriculture these days. In the oldest form of traditional agriculture, known as subsistence agriculture, farming families produce only enough food for themselves. An important definition on this slide is polyculture, or different crops planted in one field. And here we can just see traditional agriculture is really backbreaking work, and often subsistence farming is often a product of traditional agriculture. It's hard work, and you can only grow enough for yourself. So farmers replace horses and oxen with machinery that provide faster, more powerful means of cultivating, harvesting, transporting, and processing crops. Such industrial agriculture also boosted yields by intensifying the irrigation and by introducing synthetic fertilizers. In addition, the advent of chemical pesticides reduced competition from weeds and herbivory by crop pests. For maximum efficiency, the new agriculture required the uniform planting of a single crop, or a monoculture, which is distinct from the polycultures typical in traditional agriculture. Beginning around 1950, the Green Revolution introduced new technology, crop varieties, and farming practices to the developing world. So with new technology, large-scale farming became possible, and monocultures became the popular method of farming. So soil is a system. It forms very, very slowly. It contains 50% mineral matter and up to 5% organic matter. And this is from dead and living microorganisms or decaying material from plants and animals. So that's why the no-till method might be really attractive, is because organic matter from the plants left over after harvest, they can incorporate their organic matter into the soil. And the remainder is pore space taken up by air and water. And soil is just teeming with bacteria, algae, and just a lot of little organisms. And also, since soil is composed of interacting living and non-living matter, it's considered an ecosystem in its own. So as you can see, soil is rather complicated with everything that goes into it and lives in it, and it's really not just dirt. If it's just dirt, it's not a healthy soil. So parent material is the base geological material in a location, and bedrock is the massive solid rock that makes up Earth's crust. The weathering of parent material is the first step in the formation of soil. Once weathering has produced fine particles, biological activity contributes to soil formation through deposition, decomposition, and accumulation of organic matter. Weathering and the accumulation of and transformation of organic matter are the key processes of soil formation, and these are influenced by 5 factors. And these 5 factors are climate, organisms, topography, parent material, and time. Because forming just 1 inch of soil can easily require hundreds or thousands of years, we would be very wise to conserve the soil we have and start on maybe producing a bit more now. So just a couple definitions. A soil profile consists of horizons, and each layer of soil is then known as a horizon, and the cross-section as a whole from surface to bedrock is known as a soil profile. The simplest way to categorize soil profiles is to recognize A, B, and C. Horizons correspond respectively to topsoil, subsoil, and parent material. Minerals are generally transported downward in the soil as a result of leaching, the process where solid particles suspended or dissolved in liquid are transported to another location. A crucial horizon for agriculture and ecosystems is the A horizon, or the topsoil. Here we have an example of a cutaway of various common soil horizons. The letters correspond to various things, but we're not really going to go into that now. Just know the A, B, and C. So leaching in the soil, it works a lot of the same way as the coffee grounds get through a filter. Is water with the nutrients just makes its way downward. So soils are very different in amongst themselves. They differ in color, texture, structure, and pH. Soil scientists classify soils, and farmers judge their quality for farming based largely on proportions or properties such as color, texture, structure, and pH. To a scientist or a farmer, the color of a soil can indicate its composition and fertility. Soil texture is determined by the size of particles. So clay consists of particles less than 0.002 millimeters in diameter, silt of particles 0.002 to 0.005 millimeters, and sand of particles 0.05 to 2 milliliters. Or 2 millimeters, geez. Soil with an even mixture of the three particle sizes is then known as loam, and soil structure is a measure of the clumpiness of soils. Plants can die in soils that are too acidic or alkaline, so soils of intermediate pH values are best. So this is how soils are classified. It's by the proportion of the clay, sand, and silt particles. So I already talked about this, but yeah. Soil structure is a measure of the clumpiness. Plants die in soils that are too acidic or alkaline. So cation exchange is something that's pretty vital for plant growth. Plants gain many nutrients through a process called cation exchange. And this cation exchange expresses the soil's ability to hold cations and prevent them from leaching, thus making them available to plants. This is a useful measure for soil fertility. Regional soil differences affect agriculture. So as I was saying, soil really differs in amongst itself, and soil characteristics then also vary from place to place. In rainforests, the nutrients are in the plants, not the soil. Because it rains so often, the minerals leach rapidly and aren't very available for plants for uptake. However, rapid decomposition of leaf litter results in a thin top layer with little humus. So this is what we're talking about here. The A horizon, the topsoil one, is thin or absent humus. Basically what happens is the nutrients, they just leach out due to a large amount of rain. So all the nutrients and elements are just kept in the plants themselves. Yeah, as I was saying, the nutrients are in the plants, not the soil. Rain leaches minerals. Yeah. And this is a really big problem for when the plants are cut down. Soils are poor, and rapid regrowth is not really possible. And here's an excellent picture of a cutaway. This is not real topsoil. This isn't soil good for growing. Rapidly, that is. So lastly, we're going to talk about Swidden agriculture for this particular topic, and it's traditionally used in tropical areas. And after cultivation of a particular product, a plot is left to grow back into forest. Soils are depleted if not given enough time. This is a very time-consuming process. And then temperate prairies have lower rainfall and less nutrient leaching and are able to build rich topsoil. So really depending on where you are in the world, it can really affect your soils. Yeah, here's what we see. In the rainforest, the soil is not very good at growing. But if you've ever been to Iowa, it has a very rich black color, and they just grow corn literally everywhere. So soil is pretty important. We've been talking about that, and what else is really important is conserving our soil, because it may take hundreds of years to grow even a single inch. So damage to soil and land makes conservation vital. Throughout the world, especially in drier regions, it has become more difficult to raise crops and graze livestock as soils deteriorate in quality and decline in productivity, and this process is termed soil degradation. Soil degradation is central to a broader problem known as land degradation. Land degradation refers to a general deterioration of land that diminishes its productivity and biodiversity and impairs the functions of its ecosystems and reduces the ecosystem services it offers us. I already read that one, okay. And here's what we see, a very moving picture. This farmer, his soil is completely degraded, and on the right we have a couple causes of degradation. It's a lot of overgrazing. Cutting down trees is a big one. When you cut down the trees, the water from rainfall events just wash all the soil away. Cropland agriculture is very similar to deforestation. So erosion is something that threatens ecosystems. I was just talking about it. Erosion is the removal of material from one place and its transport toward another by the action of wind or water. Deposition occurs when eroded material is deposited at a new location. Flowing water deposits nutrient-rich sediment in river valleys and deltas. Now, this is a reason floodplains are an excellent place for farming. If you think about the Nile in Egypt, erosion often occurs faster than soil is formed. It tends to remove topsoil, the most valuable layer for plant growth. And here we see an example of erosion. So, people have made land more vulnerable to erosion in 3 ways. And those 3 ways are over-cultivating fields through poor planting or excessive tilling, grazing rangeland with more livestock than the land can support, or clearing forests on steep slopes or with large clear cuts. So to minimize erosion, we can erect physical barriers to capture soil, but we also have other methods too. Planting plants prevent soil loss also by slowing wind and water. So the roots, they hold the soil in place. No-till agriculture leaves plant residue on fields, or cover crops, or plants you plant when you're not cultivating a cash crop. These crops, their whole use is just to hold the soil and prevent erosion. Soil erosion is definitely a global issue. Humans are the primary cause of erosion. Our activities move over 10 times more soil than all natural processes combined. Conservation farming decreases erosion rates over conventional agriculture, which just makes sense. There's a couple facts here. I'm not going to read through them. Here's just a bar graph. So conventional agriculture, a mean erosion rate is in 4 millimeters a year, and then down on the conservation is 0.015. Conventional agriculture is so far up there, they really had to break the graph, even include it on the same one. Otherwise, it would just tower over all the other ones. Desertification reduces productivity of arid lands. Desertification is a loss of more than 10% productivity due to soil erosion, soil compaction, forest removal, overgrazing, drought, salinization, climate change, water depletion, and other factors. Desertification is expected to grow worse as climate change alters rainfall patterns, making some areas drier. Soil degradations on dry land is due primarily to erosion by wind and water. It's rarely a soil structure problem or a chemical problem. Although chemical can be significant too, it's often wind or erosion. If there's nothing there to hold the soil there, it will just go with just about anything. So desertification affects 1/3 of the plant's land area in over 100 countries and endangers food supplies for over 1 billion people, and it costs a ton of money to fix every year. It's intensified by positive feedback. It forces farmers onto poorer lands, and they reduce fallow periods, so the land loses nutrients. So the land just gets worse and worse. And one really big one that we probably all heard of is the Dust Bowl that shook the United States. Large-scale cultivation of the southern Great Plains of the United States, combined with a drought in the 1930s, led to dust storms, destroying land and affecting human health in the Dust Bowl. And it really forced thousands of farmers off their land. Here we can see a picture of a dust storm, and on the B we see the Dust Bowl region and just how much of America was affected by this. So the Soil Conservation Service pioneers measures to address soil degradation, and they're broken up into conservation districts, and these districts promote soil and conservation practices at around a county level. They operate with federal direction, authorization, and they're funding and organized by the states themselves. So in 1994, the SCS was renamed the Natural Resources Conservation Services, and its responsibilities were expanded to include water quality and air pollution control, and not just soil quality control. So here's a couple of people dedicated to the conservation of soil. This thing is thriving worldwide. The SCS and NRCS serve as models for efforts around the world. The majority of farmland in several countries in South America use no-till farming, and this has resulted from grassroots farmer organizations. It's helped by just about everyone from every sector. So farmers protect their soil in many ways. Crop rotation is the practice of alternating the kind of crop grown in a particular field from one season or year to the next. Contour farming, on the other hand, consists of plowing furrows sideways across a hillside, perpendicular to a slope and following the natural contours of the land. Terracing, on the other hand, transforms slopes into a series of steps like a staircase, enabling farmers to cultivate hilly land without losing a huge amount of soils to water erosion. And that's what we see here. Crop rotation, different plants planted at different times. The contour that follows the land rather than just in a big rectangle. And then terracing, it builds up like a staircase. So the planting of different types of crops in alternate bands or other spatially mixed arrangements is called intercropping. Shelter belts or rows of trees or other tall shrubs are planted along the edges of fields to slow the wind or the water. And then conservation tillage describes an array of approaches that reduce the amount of tilling relative to conventional farming. And here we have examples of all of them. The intercropping various species in alternating rows. Shelter belts are a great way to reduce stormwater runoff. And it's just plants of just rows of taller plants such as trees between rows of crops. And lastly, no-till farming. We've been talking about this since the beginning. It's just not tilling the land and leaving the old plant residue. So no-till farming has many benefits. That's probably why we talk about it so much. By increasing organic matter in soil biota while reducing erosion, no-till farming and conservation tillage can restore soil quality. By adding organic matter to the soil, no-till farming captures carbon that otherwise would make its way to the atmosphere and instead stores it in the soil. In addition, because no-till farming reduces tractor use, the farmer burns less gasoline. No-till and conservation tillage methods were pioneered in the United States and the United Kingdom, but are now most widespread in subtropical and temperate South America, and has many benefits we have listed here. You can take a little bit of time to read through it if you wish. However, critics do exist, and critics of no-till farming in the United States know that this approach often requires heavy use of chemical herbicides because weeds are not physically removed from fields, and synthetic fertilizer because non-crop plants take up a significant portion of soil nutrients. Proponents, however, point out that farmers have departed from the industrialized model by relying more heavily on green manures or dead plants as fertilizers, and by rotating fields with cover crops, including nitrogen-fixing legumes. Critics counter that green manures are generally not practical for large-scale intensive agriculture. And as you can see, around 40% of the U.S. is using conservation tillage here. And in fact, a lot of Iowa has a lot of no-till farming counties, the yellow ones. And actually have very few counties that practice conventional intensive tillage. Plant cover is a key to erosion control. I've been talking about this a good bit too. Farming methods to reduce erosion have one goal, and that's to keep the plant cover in place. And you can move livestock to prevent overgrazing, cut fewer trees in an area rather than clear cut, or plant vegetation along riverbanks and roadsides. China's huge tree planting program slows erosion, and the only real problem with this is they're monocultures of trees and they're not really ecologically functioning forests. And this is a picture. So overgrazing can degrade soil. When too many livestock destroy too much of the plant cover, impeding plant regrowth and preventing the replacement of biomass, the result is overgrazing. Non-native and invasive species often invade too. They're less palatable to livestock, so they're not eating. And we're talking about plants here. These plants will then outcompete native vegetation. Another problem with livestock could be trampling compacts the soil and it prevents water infiltration, which is a very important soil function. And here's just a little graph of all the things that go wrong. You can take a bit of time to read it if you'd like. So degraded rangeland costs around $23 billion worldwide, and grazing exceeds the sustainable supply of grass in India by 30%, and in parts of China by up to 50%. U.S. government subsidizes increased harm. Ranchers pay little to graze their animals on public lands. few incentives to protect rangeland. It's called the tragedy of the commons. You can look that up yourself. Ranchers are now working with environmental scientists on a way to raise more livestock more sustainably. And as you can see, it's a lot of livestock here, but you don't really see much plant matter other than those really ugly bushes. So now we're going to talk about irrigation. You have to water and fertilize crops, and that's going to be the next section we talk about. Irrigation, it boosts productivity, but it can also damage soil. The artificial provision of water beyond that which crops receive from rainfall is known as irrigation. Here's a couple of examples of irrigation systems, and it's actually an interesting fact that irrigation takes up to 70% of the water used by humans. Sustainable approaches to irrigation maximize efficiency, so matching crops to the climate can reduce or eliminate the need for irrigation. Growing cotton in dry climates requires extensive irrigation, while wheat might not. Also, conventional irrigation, as little 43% of the water is supplied and is used by the crops. And then, so what I'm saying there, I messed up pretty badly. Conventional irrigation, as little as 43% of the water used, is actually applied to the crops. And then lastly, drip irrigation targets water directly to plants, and plants can use as much as 90% of the water. And here we have examples. In conventional irrigation, it's really just shooting water everywhere. And then in drip irrigation, it's a very targeted, little bit amount of water, just as much as the plant needs. So there's way less waste there. And lastly, salinization and waterlogging are easy to prevent, way easier to prevent than to correct. Over-irrigated soil saturated with water may experience waterlogging when the water table rises to the point that water drowns plant roots, depriving them access to gases and essentially suffocating them. And a more frequent problem is salinization, the buildup of salts in surface layer soils. So, as I was saying, it's easier and cheaper to prevent it than fix it. Do not plant water guzzling crops in sensitive areas. Irrigate with low salt water, and irrigate efficiently only as much as needed. Fixing requires flushing soils with large amounts of water, which we're trying not to use as much water as we can. So we've all heard of fertilizers. Fertilizers, they boost crop yields, but they're often very over-applied. We go to great lengths to enhance nutrient-limited soils by adding fertilizer, which are substances that contain these essential nutrients. There are two main types of fertilizers. There's the inorganic fertilizers, and they're mined or synthetically manufactured mineral supplements. And the other type is organic fertilizers, and they consist of the remains or waste of organisms, and they include animal manure, crop residues, fresh vegetation, and compost. And compost is a mixture produced when decomposes break down organic matter such as food and crop waste in a controlled environment. You really just see the difference. The inorganic fertilizer is usually chemically or synthetically created, and organic fertilizer is something that just is very natural. So fertilizers boost crop yields, but they can be over-applied. Traditional agriculture relied on organic fertilizers. The Green Revolution brought on increased use of inorganic fertilizers, and they are more susceptible to leaching and runoff. Runoff into surface waters from the point of application can cause hypoxic zone in water bodies. We talked about that last lecture. Nitrates volatilize or evaporate in the air and contaminate groundwater, and nitrates and phosphates in drinking water can have multiple health effects. So as we can see, fertilizer use has only increased throughout the years, and in the bottom right we have an infographic on how this fertilizer can affect not only the nitrogen cycle but also ecosystems in our lakes and rivers. So sustainable fertilizer involves targeting and monitoring nutrients. Nutrients can be added to drip irrigation and delivered directly to the plants, again, so we don't have to just throw a bunch out there and hope something sticks. No-till planting also allows the application of fertilizers with the seeds rather than spreading all across the soil. Monitoring of these nutrients can prevent unneeded applications, so if we monitor it, it may help us better plan on how to use fertilizers. Organic fertilizers provide needed nutrients as well as improving soil structure. It improves the actual soil structure, the nutrient holding capacity, and the water retaining capacity. It's very natural and it really increases the health of a soil. So now we're going to get into agricultural policy. Governments have long used policy to encourage agricultural production. It's the lifeblood of a nation and a people. Recent policy has tried to lessen the environmental impacts of external costs, and market forces should discourage practices that degrade the land, but degradation occurs slowly anyway. Farmers and ranchers cannot go without profits in the short term. It is a big problem we have, because then there would be no farmers and ranchers. Governments spend billions on farm subsidies that may be unsustainable. Some subsidies support growing water-intensive crops in desert regions, which really makes no sense. Some encourage use of easily degraded land, and proponents argue that uncertainty of crop success justifies subsidies. Grazing on federally owned land costs $1.35 per animal unit per month, and this low cost encourages overgrazing of these lands. And as we said earlier, ranchers are teaming up now to prevent loss of rangeland. And another part of the world that has been impacted by agriculture has been the wetlands. Agricultural policy have been drained for farming, or agricultural policy have allowed wetlands to be drained for farming for years now. Many of our crops grow on the sites of former wetlands, which are swamps, marshes, bogs, river floodplains that people drained away and filled in. But under the Wetlands Reserve Program, the U.S. government offers payments to landowners who protect, restore, or enhance wetland areas on their property. And it's been met with middling success at times and less so at others. So a number of programs promote soil conservation, and that's what we're going to talk about next. The Conservation Reserve Program pays farmers to stop cultivating damaged, highly erodible cropland, and instead makes these lands conservation reserves planted with grasses and trees. And lastly, internationally, the United States promotes soil conservation and sustainable agriculture through a variety of programs led by the Food and Agricultural Organization, or the FAO. Just a couple quick facts here. I'm not going to read them. Now lastly, we're going to get into the conclusion, and this is right before the lecture ends. Many of the policies enacted and the practices developed to combat soil degradation in the United States and worldwide have met with success, particularly in reducing topsoil erosion. In light of continued population growth, we would need better technology and wider adoption of soil conservation techniques if we are to achieve sustainable agriculture and feed the 9 billion people expected to crowd our planet by mid-century. That's going to be it for the lecture today. I know it was a long one and I made a lot of mistakes.